Assalamualaikum warahmatullahi wabarakatuh. My name is Haji Azhar bin Madul Zaman, CE210187, and this is my final project presentation. For my project title is Human Detection and Carbon Monoxide Monitoring System for Vehicle Safety using IoT Platform. For the introduction, first of all, we want to introduce with the importance of the vehicle safety innovations, and beside that, the uh, needed of role IoT in modern safety system. Basically, IoT right now already increased their needed for the environment, especially not just in industries, also in the safety or security part. And basically for our project, the key safety gap that we want to focus on is first, lack of carbon monoxide monitoring system in vehicles. As you can see, all cars right now do not have a gas monitoring system, which is it's actually the even the incidents about gas detection, fatalism not happen very much, but it's important to take focus on because it already have a incidents that uh, kill someone about the carbon monoxide. And number two is to create the absence of human presence detection for unattended passengers. As an example, child. So this is our problem statement for the topic. First of all, the challenge is about unattended passengers, especially children, that exposed to carbon monoxide more dangerous than the elders. And beside that is current safety system in car do not have fail to have addressing carbon monoxide monitoring and other that also other gas that dangerous to humans health. And number two is the impact. What the impact if we do not solve this problem? First, it can serve health risk and also even give a fatalities to human. And its need for integrated and proactive safety solution before the incidents happens more often. So my project objective is to develop. This is main goal. First, is to develop an IoT-based system for human detection and CO monitoring. But the specific one is, I want to create a real time. This project is want to create a real time alerts via smartphone. And number two is to integrate of carbon monoxide sensors and cameras. And number three is to do a testing and evaluation on project prototype. And for the methodology, we have two first system components and workflow. For the system components, the hardware we use is MQ7 sensor to function as a gas detector and gas monitoring. And number two is webcam used as a face detection. And number three is we use microcontroller ESP X266 and servo motor used to control the Windows prototype. And for software part is we use Android-based app to create an apps by using a Flutter, and also we connecting with a Firebase as a database cloud database. And this is our workflow, starting with data collection from camera and also gas sensor. After that, we will use a real-time analysis, which is we will save the data in the Firebase, and we will transfer the data to application, real-time application, real-time monitoring, and it will send a notification as needed. So the result, this is our result. First of all, for the performance metric, so level only can detect for the accurate part is only can detect 20 until 2000 ppm. But in our project, we successfully detect the carbon monoxide, and also we successful in human detect human presence detection, and we also successful to send a notification when the requirement needed. Number two is prototype testing. When the requirement, which is if there's person in the car and also the ppm increase in the level dangerous level, the system will automatically open the windows, and basically this is app-based real-time alerts. for the discussion for this project achievement, it integrated safety features for vehicles and proactive monitoring system, but it also have a limitation, which is the daylight is dependent detection, which is in the night it cannot function properly because the webcam only can detect in daylight, and the prototype scale for the testing project only. This is our demonstration. First, we need to fire the things and then we insert in the prototype. And this is our real-time database from the gas sensor. And this is webcam that will detect your face, and all of the data will insert and will get the noise will get the data. When the phase is more than 0 and the gas level is more than 50, the servo will on and it will uh, it will include the gas carbon monoxide gas in the car. But if the gas is reduced to 20, and it will close again the windows. So basically, this is our project, and this is my apps monitoring system. And for in this app monitoring system, we have four type of notification. First, if it detect a person, and it will send notification. If the detect a person and gas level is more than 10, it will send a notification. If more than if it detect more than 30, it will give a dangerous level notification, more more specific. And lastly, if it detect the gas level is more than 50, it will send notification about the windows is open. So that's all for our project. As a conclusion, the key takeaway is this project is to want to enhance a vehicle safety through IoT, and also address a critical gap in CO monitoring system in the vehicle safety. For the future work, we can scale the hardware integration for diverse type of vehicles, and also we can improve the app's scalability and also the system energy efficiency that we can use in the real time real world application. And that's all for my presentation. Thank you very much.